Welcome to the Advanced Arduino Basic project, and today we will learning about Smart Home Automation System. And here is the agenda: overview, components, principle and procedure of Smart Home Automation System. Overview: in this lesson we will program the Arduino to achieve the automation of a smart home system. The system will automatically control the light, fan and detect gas leakage and water level using distance, motion and temperature sensors. The required components are Arduino Uno ultrasonic sensor, PIR motion sensor, gas sensor, DC motor, LED, relay, buzzer, breadboard and jumper wires. Principle: the core principle of this project is automated safety and resource management using a condition-based logic system. It operates on three main functional pillars: environmental monitoring, intrusion and lighting control, water level hysteresis. And this is the schematic diagram. And next is the procedure: build the circuit. So this is Arduino Uno microcontroller and this is PIR sensor. So it detects motion. So when it detects motion, this bulb will glow and buzzer will be turned on. And this is motor, this is gas sensor. So when it detects gas, the buzzer will turn on. And this is ultrasonic distance sensor. So it is used for the water level management, and this is the thermistor. And next is the program. This is step 2. So first we need to declare the pin numbers: sensor pin and buzzer pin, bulb pin. And next is the constant. So here we define the constant of gas threshold, temp threshold, water empty distance and water full distance. And then thermistor constant, series resistor, temperature nominal, thermistor nominal and B coefficient. And here bool motor status false. So this is state variables. Bool is a data type, so it store either false or true. So here motor status false. And next is the setup function. So it will tell whether these pins are input or output. So PIR pin is input and buzzer is the output. And initially we consider these as low. Buzzer is low, bulb low, motor pin low. And this is used for the serial monitor. So we will print the statement using serial monitor. And next is the loop function. So it will run repeatedly. So here also we use boolean data type, and alarm active is a variable. So here we consider it as false initially. When the loop starts, the buzzer flag is turned off state. Buzzer is turned off. And next is the motion detection. The code constantly checks the PIR pin for a digital signal. So here the if statement. If the sensor sends a high signal, it means the motion is detected. The Arduino immediately turns on the buzzer and bulb. Here you can see bulb pin is high. It waits. Then after that it prints motion detected, bulb on. Then turns them off if no motion is detected. So here you can see bulb is off. And next is the gas detection. The code monitors air quality and heat to prevent accidents. So it reads the analog value from the gas sensor. So if the value exceeds than the gas threshold, it triggers the buzzer to warn of a leak or smoke. So then it prints gas leakage is detected, and along with the gas level, the value of gas level. And next is the temperature detection. So it reads the thermistor value. So here you can see thermistor pin. So here we use mathematical formula, that is Steinhardt equation. So it is used to convert raw electrical resistance into Celsius temperature. Here you can see, first we get the value of resistance. After that, by using the value of resistance, we find the value of Steinhardt. Then Steinhardt equals to Steinhardt plus 1 divided by temperature nominal plus 273.15. So then by using this value, we need to find the temperature Celsius. If the value of temperature Celsius is greater than the temperature threshold value, so it sounds the buzzer as a heat warning. Then it prints this statement, high temperature alert. Next is the water management. So here we use ultrasonic sensor. The code uses a custom function that is called get ultrasonic distance. So it is used to measure how far away the water surface is using. So that is using the pin number 6. So here we connected ultrasonic pin to the number 6 digital pin. So it briefly turns the pin to output to send a sound wave, then switches it to input to listen for the echo. It compares the distance to a threshold of, here we have already defined the values. So it compares distance with these values. So if distance is greater than water empty distance and distance is less than 400 and also motor status is false, then in serial monitor it prints water empty and motor on. So if this statement is false, then motor status is true. Next is the else if condition. If distance is less than water full distance and another condition is motor status is true, then it prints the serial print water full, motor off. It prints only when the motor status true, and if motor status false, it will not going to print this statement. Next is the final buzzer control. So this buzzer, if ultram active means buzzer is high. If ultram active is low means buzzer is low. Means buzzer will be turned off. So if ultram active buzzer pin is high means buzzer will be turned on. And here in the serial print, G value means gas value, T means temperature in Celsius, W means distance value. And float is a data type, get ultrasonic distance of means, so this one means ultrasonic pin value is output. Here we considered ultrasonic pin as an output and this is low. after some microsecond delay it should be high, then again it should be low after some delay. So long duration equals to pulsing of ultra pin high 25,000, and if duration equals to 0 return 10. Float distance equals to duration into 0.34 divided by 2. So 0.34 is the speed of light, then it will return the distance value. And next step is compile the program and upload to Arduino Uno board. So open Tinkercad, login, circuits, then place the components. So first we need to place the components. Arduino board, then breadboard, then LED, this temperature sensor, PIR motion sensor, then ultrasonic sensor, and then here, sorry, this one is temperature sensor, not this. Yeah, then we need buzzer, PIR Arduino buzzer, temperature sensor, then bulb, search it here, bulb, yeah, then motor, yeah, DC motor, then we need to relay, so this is battery, search relay, SPDT, and we also need gas sensor, search it here, gas sensor, yeah, let's do the connections. Before that, place components properly. So yeah, I'll place this here, and breadboard, this is battery, then we need temperature sensor, motor, I'll place it here, then ultrasonic sensor, and this gas sensor, copy, Ctrl C, then Ctrl V and paste it here, and this LED, yeah, this one, this is not required, then breadboard is required, one more breadboard, so mini breadboard, search mini breadboard, yeah, this one I will keep it here. Yeah, that's all about the placement. Now we need to connect all the components one by one. So first power, I will connect first power, so I will connect this to positive rail and change the color. Yeah, this is the power pin connection, and next here ground pin, we need to connect this to the negative rail of the circuit. So this is the PIR motion sensor, so change it to black, and this signal pin, I will connect this to pin number 4. So I will change it to orange. So this is the PIR motion sensor connection. It is used to detect the motion. Yeah. And next connection is buzzer pin. So I will connect this to pin number 3. So if you want to use this breadboard, yeah. Now pin number 3. Buzzer connection, and this should be connected to negative rail. This is the negative rail. Black. And one more thing, we need to connect this to the negative rail and positive +5 to positive rail. So here +5, yeah, and we need to short these two. This is positive rail and this negative rail to negative rail. Yeah, shorten this down. And next ultrasonic pin. So this power pin, we need to connect this pin to the positive rail. Yeah, this is positive rail. And next is the ground pin. So this is negative rail. So this ultrasonic sensor is used to detect the distance, and this I will connect it to Arduino pin number 6. So taking like this. This pin, I will connect this to pin number 6, and I am changing it to green color. Yeah, ultrasonic connection is over. This one over. Now temperature sensor. So power pin should be connected to the positive rail. So yeah, this is positive rail. I am changing the color, and this V out should be connected to the analog pin. Here I am connecting to A0. I'm changing the color. Then this ground pin should be connected to the negative rail. So here I am connecting this to here. Just move it. Yeah. Sorry. Yeah, this connection is over. Now we need to connect this to positive rail. So here I am connecting positive rail, and then we need to short 3 pins. This one done. Now lower part, this should be connected to the negative rail. So here I am connecting this to and change the color. And this pin, analog pin A1. So here I am connected this pin to analog pin A1, and I will change the color to purple. And this pin also I will connect it to ground. But here I need one resistor. Using this resistor, this connection is over. Now we need to connect. So this battery negative should be connected to the negative. So we need to change the color here also. Wrong pin. And this positive should be connected to this rail. This is positive. This is motor. So for motor we using this 9 volt. So this terminal, I will connect this to relay. Here we have 2 relay, right? And this is for ground, so I am connecting this to negative rail of the breadboard. And here we having one more pin. I will connect this pin to Arduino. Pin number 9. So this is the relay connection, and this bulb negative means cathode. I will connect this to increase. I will place it here. It's easy to short both pins. Yeah, now I'll change this color to black. Then one more terminal of the motor, I will connect this to here. Yeah, now we will short this too. Yeah, now this one done. Now we need to connect this anode terminal to this relay. This pin should be connected to the Arduino pin number. So here I am connecting this to pin number 9. So I already connected, right? So this one I will connect pin number 5. This should be connected to the negative rail. So why I connected to pin number 5 this relay? Because in code we have considered for this relay pin number 5. If you want, you can connect it to the pin number 9 also. No issue. Connection is done, right? Connection part is done. So next is the code. Click start simulation. We having error, right? Series resistor was not declared in this. Float resistance equals to here we having dot. Just remove this dot. Start simulation. Now open serial monitor. Here you can see it printing gas level, temperature value and buzzer also turned on. Why it's giving alert? Because here temperature value is greater than the threshold value. Now we need to reduce the value of temperature. So 39 is there, right? Here we need to make it 40. Just for testing purpose I am making it to 40. And now see. Again vary this temperature value. Now buzzer is turned off. So temperature alert is not there. So based on the temperature, here you can see the motor speed is varying. Where it is, so based on this it's varying. Now you can see the speed of motor. And this is PIR motion sensor. So when it detects motion, the buzzer will be turned on. And why bulb is not on? Let's see. Connect this relay pin to pin number 2. Arduino pin number 2. Let's check again. So when PIR motion sensor detect motion, bulb will glow. And next is the gas leakage detection. Maximum value is 322, right? So I'll change this to 250. Sorry, top simulation. Let's see. So here gas leakage is detected. Move this. Now there is no gas leakage. This is about the gas leakage detection. And next is the water level management. Here you can see by varying this we can change the level of water. So here you can see the water level is changing. So reduce it. See here, water full, motor off. Yeah, now again water empty, motor on. So this is the water level management. So these all are the requirements of home automation, isn't it? So it having 4 major advantages. So security and lighting, then air safety, then climate monitoring, then automatic water pump. The system acts as an intruder alarm and automatic light. So when the PIR motion sensor detects movement, the Arduino immediately turns on buzzer to sound an alarm and switches on the bulb to provide light. So once the motion stops, means when it detects the motion, then only on. So when it stops detecting, see, now there is no motion, right? Yeah, now both turn off automatically. And this is gas sensor. It constantly check the air for smoke or harmful gases. If the air quality drops and gas level crosses a preset safety limit, so here we considered 250. The Arduino triggers the buzzer. This provides a practical warning system for gas leaks or fire hazards in the home. And next is the climate monitoring. The system uses a thermistor to monitor the room temperature. The Arduino performs complex math internally to convert electric resistance into a Celsius reading. So here we observe, right? If the room gets too hot, the buzzer sounds to alert you to the high temperature, which could indicate an overheating appliances or fire. If there is no overheat, it also control the speed of the fan. And next, automatic water pump. It's like, so this uses an ultrasonic sensor to measure water depth. It follows a simple logic to ensure you never run out of water. So refill and stop. So if this sensor detects the water is too far away, meaning the level is low, it turns the motor on. Once the water level is high enough, so it shuts the motor off to prevent water overflow. So that's all about the today's project, that is Smart Home Automation System. For more project, please watch the upcoming videos. Thank you all.